Hi everyone, this is 2.1 number 10 and we are being asked to design a cylindrical can. So here's sort of a rough sketch of the shape of our can. We know that the volume is supposed to end up being 100 cubic inches. So we're told it must hold 100 cubic inches. That is a volume. Units should always be a good hint on things like that. Square inches are going to be area, cubic inches are going to be volume. We know that the top of the can and the bottom as well cost 14 cents per square inch. And then the material for the sides of the can is 7 cents per square inch. Okay, so first part of this problem, we're supposed to express the height of the can as a function of its radius. So with these, it's always good to ask yourself, what's restricting my choice? So if I pick an R, I can't just pick any H I want to go with it, and the question is, what's forcing my choice of H? And the answer is the volume is forcing my choice. So I know that the volume of a cylinder is pi r squared h, and that's one you should know. That's one of the prisms. So if you take any of our basic 2D shapes that we're supposed to know, circle, rectangle, triangle, and you just give some height to them. So this one is a circle that I've stretched out and given height to. It's going to be the area of the base multiplied by the height, and for us the area of the base is a circle is a pi r squared. So the prisms you should be able to do. And then the volume is actually given information, so I know that pi r squared h has to equal 100. That's what's forcing my choice. This specifically wanted h as a function of r, so I'm going to solve for h by dividing out the pi r squared. And I'm going to say, switch sides here, h is equal to 100 over pi r squared. And you can even use your function notation and say specifically that that's height as a function of radius. Part B wants us to now express the total cost of the can as a function of its radius. So cost as a function of r. Okay. My first thoughts are I'm going to have to add the cost of the top, the cost of the bottom. Whoa, that went wacky. And the cost of the sides, however you want to say that, outside. You can mush top and bottom together if you want to, but I'm going to start with this. So you don't have to write stuff like this out, but if you're having trouble getting started, any structure you can start to give yourself is a good thing. And then I know something about the cost for the top, and this is where some people start to get in trouble. I know it costs 14 cents per square inch, so that's kind of like the rate of the cost of the top, but we're not going to get the total cost of the top unless we multiply that by the area in square inches. So again, units should be really helpful. If you have dollars per square inch and you just want to know how many dollars, you need to multiply by square inches. So the area of the top is a pi r squared. The bottom is identical. So costs 14 cents per square inch and has area pi r squared square in there too many times. And then the sides sometimes trick people a little bit, but here's what you want to picture. Imagine we've taken off the top and the bottom and we're just looking at this outside, and we make a cut and then we unroll it and we lay it out flat, and what you're actually left with is a rectangle. And the height of the rectangle is the height of the cylinder, and the width of the rectangle is the circumference of the top or bottom. And remember, circumference is 2 pi r. So that's what the outside of this thing looks like. So we're going to get 7 cents per square inch multiplied by 2 pi r times h square inches. And we can simplify this a little bit. and say that C of r is going to be 0.28 pi r squared, just adding those two together. And then when we multiply the 2 in, we get 0.14 pi r h. Oh, and I'm missing one more step I need to do. This is only supposed to be a function of r. So we're going to replace the h by 100 over pi r squared. And I can actually simplify that as well. Pi's cancel, one of the r's cancel. Okay, so one more rewrite. C of r is equal to 0.28 pi r squared plus 14 over r. All right, and that looks like a great answer. Thanks for watching.